Good morning, good afternoon, or good evening, depending on where you are in the world. My name is Sharon Florentine. Welcome to today's DevOps.com webinar, Best Practices for Cloud Native App Delivery, brought to you by Red Hat and Citrix. Before we get started with today's webinar, I just have a few housekeeping items that I need to go through with you. I need to remind you that today's session is being recorded, so if you miss any or all of it, you'll be able to go back and watch it again. We are taking questions throughout the webinar, so you can use the Q&A tab on your console to submit questions throughout, and we will get to as many as possible at the end of the presentation. In addition, we're going to have a couple audience polls pop up for you. We would really appreciate it if you could take a couple seconds when you see those and submit your responses, and then we'll go over the results so you can check those out as well. Finally, at the end, we're going to do a drawing for 4 $25 Amazon gift cards, so stick around to see if you are a winner. And with that, I'm going to turn it over to today's presenters. You guys, Jacob and Pushkar, take it away.
Thank you, Sharon. Appreciate it, and welcome everyone again. Thank you for joining today's presentation. My name is Jacob Gay. I'm a solution architect with Red Hat, and I'm joined by Pushkar Patel, a product management cloud native delivery specialist from Citrix. We're very excited today to share an outstanding narrative on cloud native application delivery and an amazing demonstration of how our two products, the Citrix Application Delivery Controller and Openshift platform, work hand in hand and better together. So with that said, let's get started. Hybrid cloud, containers, and Kubernetes are powerful technologies that are driving digital transformation today across enterprise applications and their architectural patterns. The fundamental shift with how companies build and run mission-critical applications are accelerating more than now because of the impact from container technologies, which are the key enablers for IT and cloud-native application delivery. And developers now are able to focus more on coding than ever before, and operations teams are now able to maintain complex environments within a single pane of glass, thus removing friction across the silos and to the benefit of the enterprise. And again, we have a jam-packed agenda today, a lot to get into. So I just want to run through it real quick so we can get started. Again, we're going to talk about OpenShift and the value proposition. We have some exciting announcements about 4.7 that recently was announced in our summit conference. We want to get into operators and the impact they make with our partnerships with companies like Citrix. And then we're going to transition into the heart of this agenda, which is cloud native delivery for applications, and discussing the continuous integration and deployment strategies that we have today. And then once we get through that, we'll talk about the partnership with Citrix and Red Hat, and then we'll hand it over to Pushkar so he can showcase the Citrix products and then get into his demonstration. And then once that's over, we'll get into some Q&A. So like I said, a lot to get into. Let's just jump in and get started. Redhead Openshift, for those who may or may not be aware, gives organizations a single platform for application innovation that lets them operate consistently and innovate continuously. It supports every application. It can span every cloud so that organizations can be ready for today and build for the future. And as you can see here on the slide, that's with cloud native applications, artificial intelligence, machine learning, and those traditional applications with your choice to host wherever you may want to. And it's, as you may know, OpenShift includes everything you need to run a hybrid cloud, from the Kubernetes layer to the platform services that you see here, help you run your apps and the developer tools that help make them. We're going to cover what's next in all these areas today. And you might notice, if you're familiar with this diagram, that there's a new box in our infographic here. And that's right underneath the multi-cluster management section. And that's for advanced cluster security, which is the new suite of security features based off our recent acquisition of StackRox. And lastly, we'll go over some of the awesome work we're doing with multi-cluster management, which is allowing you to seamlessly scale from a single cluster to hundreds of clusters with integrated networking management, truly game changer for the hybrid cloud world. So let's get into advanced cluster security for Kubernetes, which is empowering the development teams and operations teams and security to extend scanning and compliance into that DevSecOps workflow. That workloads are born secure now more than ever. It enables teams to maintain and actually enforce a zero trust execution approach to workload protection by leveraging built-in cloud security posture management features to identify and remediate risky configurations. And finally, we're leveraging the StackRox Kubernetes native security controls, which allow you to safely segment your environments. With advanced cluster management for Kubernetes, we're providing you an end-to-end management visibility and control to manage your clusters in application lifecycle, including security, compliance for your entire Kubernetes domain across multiple data centers and public clouds. These models allow applications for multi-cluster deployment with enterprise features that help ensure both the rapid deployment of an application and the resiliency of your infrastructure. By standing up new clusters, it let the subscription framework handle the continuous delivery of your applications across all environments. And another recent announcement, which is in tech preview, is Openshift Get Ops. And the reason and the why for this product is it's in order to simplify the adoption of GitOps principles on Openshift for managing cluster configurations and delivering applications in multi-cluster environments. We're excited to announce this GitOps feature, and it's built on the open source Argo CD project, which is now included in the Openshift subscription via Operator Hub and is now available again as a tech preview. But most importantly, with the GitOps model, we're allowing users to describe the applications and services they want, and the deployment and management is done for them. GitOps pipelines are considered more secure than allowing traditional development and CI tools to access running clusters directly. So as organizations embark on their hybrid cloud journey, they are more and more often faced with the challenges of managing multiple OpenShift and Kubernetes clusters and the complexities associated with delivering these applications consistently and predictably on these multi-cluster environments, which GitOps allows a declarative approach to the continuous delivery that has been proven as an effective strategy for addressing these challenges in these multi-cluster environments. With that, I'll get into operators, which is a key enabler for our partnership ecosystem. We're very excited to showcase this with you today. And again, the Citrix Application Delivery Controller. And as you can see here in this chart, we have partnerships in all the main areas of platform services. Right, the operator itself allows you to automate the deployment and maintenance of these services and workloads. And certified operators for our partners are set to enable quick deployments of their services onto the Openshift platform. Over 100 plus today in an app store experience, which is we find very successful for our customers and our partners. And in order for operators to be as successful as they were designed for simplifying the installation as well as automating the orchestration of these complex workloads on the Openshift platform. They help encode human operational logic to manage services running as Kubernetes native applications, thus making day two operations easier. And for those there who may not be aware, an operator is a method of packaging, deploying, and managing a Kubernetes native application. A Kubernetes native application is defined as an application that is deployed both on Kubernetes and managed using this Kubernetes APIs. And again, it's all about simplifying the operations and the deployment flexibility of these services and features onto the Openshift platform. And this is all accomplished by the operator framework, which is an open source toolkit to manage these Kubernetes native applications, thus called operators, in an effective, automated, and scalable way. They take advantage of the Kubernetes extensibility to deliver the automation advantages of cloud services like provisioning, scaling, backup, restore, while being able to run anywhere that Kubernetes can run. The operator framework, again, is an open source project It's enabled to provide developers and cluster administrators the tooling they need to accelerate the development and deployment of an operator. Now, we talked about the new features in the OpenShift platform, the business value, spent some time with operators. Again, there's a lot to unpack here today, but now we want to shift into what I would consider the meat of today's agenda, which is all about cloud native application delivery through continuous integration and continuous deployment opportunities. Before we jump into this topic, we're ready for our first poll question.
All right, awesome. So, all right, that poll should be coming up on your screen right now. We'd love it if you could take a few seconds and give us your response. Do you plan to use CI/CD for your Kubernetes app deployments? Yes, no, or you're not sure? I don't know, Jacob, what do you think? I have a feeling that with this audience, we may be seeing a lot more yeses than nos.
I agree, Sharon. It's definitely going to be a lot more yeses and not sures, and I don't imagine there'll be too many nos.
Yeah.
But we just wanted to put that pulse check out there to see, what's happening in the ecosystem and to get a feel for what developers are doing today in their environments.
Yeah, good point. And maybe those, if we do get any no's, they could be considering it, and this presentation could push them over the edge. All right, we'll just give it another couple seconds, and then we will close that out. All right, I'm going to close it out, and then we will take a look at the responses here. Oh, wow. Okay. So do you plan to use CI/CD for your Kubernetes app deployments? 54% said yes. We didn't get any no's, and 46% said not sure. So that kind of aligns with what we were thinking. And Jacob, I'm going to turn it back over to you.
I think the result speaks for itself, right? So people who know the value of CI/CD, have gone full ahead. They know about it. They have put it up there, and the ones who are not gone there yet, it's fair to say they have said no, right? Or not sure, rather.
Agreed, Pushkar. And that's fantastic, because we have a lot of content to share today to help those that are not sure as they continue to progress on this journey. And so let's dive right in. So for those that are not sure about their approach to continuous integration deployment within these Kubernetes environments, we want to get into some cloud native principles that refers to how these systems work in these next gen environments with OpenShift and the Citrix application deployment controller. And first principle is the container, right? In order to be successful in these next-gen platforms, you need the containerized application that are built in an environment that is intended to run well in Kubernetes. And you may be further along. There's a lot of yeses as well, right? You could be running a serverless workload where you're running and scaling on demand without the need for a central CI engine to be maintained and taken care of. And last but not least, the DevOps, right? That mentality of how your teams work together, they're built with these practices in mind to allow them to own their delivery pipelines alongside the applications without having to rely on a center of excellence or a team that manages these pipelines on the other team's behalves. Right? We see that being the quickest way for teams to be successful and to remove that friction across those different silos. So we're merging them together. And we tie that back again to the Get Ops announcement. It's very important that we share that. And Pushkar will showcase the Argo CD today with the demonstration. We're very excited to see that. And as organizations embark on their hybrid cloud journey, they're more and more faced with the challenges of managing these multi-cluster environments. And these clusters now they're scattered across multiple clouds with so much complexities of delivering applications consistently and predictably in these environments. And again, GitOps solves this by providing the declarative approach to the continuous delivery for addressing these challenges in these multi-cluster environments. And you see that by automating installation, providing the multi-cluster config management, bootstrapping GitOps with opinionation, and also always giving you that additional telemetry data that you can have visibility into your environments so that you can understand how your workloads are performing and if there are opportunities to enhance that or to resolve any type of application issues. Now that we've talked about the cloud native solutions, such as Get Ops, we want to highlight our partnership with Citrix because that's why we're here today. They have an amazing product they want to showcase, and we're excited to be here with them to do that. And Citrix and Red Hat have been a partner for a long time. We have grown that relationship over countless years, and since 2014, it's been elevated into an advanced independent software vendor partnership. And the joint value proposition of Citrix and Red Hat better together is how they have operators for their CPX, their Ingress Controller, which again eases the deployment of these solutions. But again, today we're here about the ADC, and these are layer 7 policies, which in the ADCs can configure into the Citrix stack solution, which is all about accelerating the OpenShift cluster migration of apps to microservices. Now we'll get into 2 specific use cases on the next slide, but just wanted to showcase all the different highlights and certifications that the partnerships have together, including OpenShift, Ansible, and Red Hat Enterprise Linux, our flagship operating system product. So with that said, let's get into the use cases. The first one, which is one of my favorites because I'm a cloud strategist, is about cloud migration, helping customers adopt these amazing technologies that OpenShift has available for you today, right? And allowing you to have freedom of choice of where you want your workloads to be. And in the process of just moving it from an on-prem data center or public cloud or back to an on-premise data center, the Citrix ADC instances, they allow you to configure across these environments, leveraging Ansible for different use cases. Again, accelerating the migration of your workloads into these environments by providing failover solutions such as load balancers, and again, leveraging the Ansible playbooks to automate this so that there's no human error when you go into the migration. And with number 2, it's all about accelerating the agility that you have with integrating your network environments into your pipeline. So you're streamlining the changes that you make to your infrastructure environment, your connectivity, your policies, your protection of your workloads in a streamlined fashion so that it isn't an ad hoc feature. You're enabling automation to leverage network configuration as a security policy. And Ansible allows you to integrate that with our CI/CD tools so that it can be infrastructure as code. And again, removing that human error from manual configuration. And the benefits here are obvious to us that have been leveraging these products, and that's accelerating time to value, improving your developers' velocity, reducing intervention from your NetOps teams, like telling you to stop what you're doing because they think you're breaking something. And again, eliminating manual configuration errors through automation, which I think everybody here that works in these type of complex environments can definitely showcase their appreciation for what they do for our day-to-day jobs. So with that said, I'm gonna hand the mic over to Pushkar Patel, and he's gonna take over and showcase some of the great things that we're doing together.
All right. Can you guys hear me?
Yes, we can hear you, Pushkar.
Sure can.
Sure. So let me just pull up the presentation. Okay, I think. All right. So I think we have a lot of content to cover. I want to showcase our partnership with Red Hat OpenShift and Red Hat ecosystem, and then also show you actually things in action, right? How we can deliver application, resilient and secure application, and what are the best practices around it, and how Citrix can help you use those best practices, right? Just a brief introduction about Citrix. If you don't know, Citrix is well known for its virtualization solution. There is another business arm of networking as well, which becomes a very important component for delivering those virtualized app. We call it Citrix App Delivery and Security. We have like 40,000 plus customers. And, think about any hyperscaler we are present there. The Amazons of the world, the Apples of the world, the Googles of the world. We are solving their problems with our product. And then for the past 10 years, we have been in the Magic Quadrant for the last 10 years. So the innovation is on, right? We provide very high flexibility of using our product in these different environments. So what it means is you also need to have these products available in these different environments. And it comes with the foundation of software first principle, right? So we started off with hardware appliances with the software first principle in mind. And then as the business changed, as the virtualization took off, we created a virtual form factor of the same application delivery and security product. And then, the public cloud took off. So, we had to be there solving their business problems over there. So we are present in the major public clouds as well, Amazon, Azure, Google Cloud. And then around 2013, 2014, as the Dockerization or the containerization took off, we also introduced a container form factor of this application delivery and security product. And our most recent solution is a bare metal solution where you can bring out of off-the-shelf hardware, x86-based hardware, and run Ubuntu or CentOS, and you can literally turn on a full-blown Citrix ADC on that. The main value across all of these products, these different form factors, is it is built out of a single software code base. So this allows you to have consistent features across all of these. You can leverage same APIs across this, which makes us very easy to integrate into various orchestration platforms, right? So by orchestration platform or IaaS platform, I mean, you go to Amazon, they have their own way of implementing, and they can leverage our APIs to integrate there. Talk about OpenShift on Kubernetes ecosystem in general. Again, it's the API first world kind of an environment, and having this consistent API allows us to be placed in these different environments in a Kubernetes cluster or outside the Kubernetes cluster, in the cloud or on-prem, right? So, what's the value we provide across all these different hybrid and multi-cloud environment is, of course, having these different form factors. Along with these different form factors of ADC, it is the kind of feature sets we bring to the table, right? Right from various load balancing algorithm to things like web application firewall, doing SSL termination at scale. So that single pass architecture and a common code base adds a lot of value, right? And high performance is key in these environments. The customer experience when they access a website is become very important, and having high performance is absolutely crucial. So we take performance very seriously. And to manage all these different ADCs across these different environment, you need to have a common control plane. So we have developed a common control plane which can be used to configure and manage these ADCs in these different environments. Not only that, once the things are in operation, understanding what the applications are doing, how they are performing, and then kind of planning even before any massive event happens, which can take things down. Observability and machine learning based predictive analytics become very important. So that is also built in cohesively in our product. And to consume these ADCs across these different environment, we provide very flexible licensing, and that helps in lowering the TCO a lot. So now I think Jacob has covered this. Red Hat is an amazing partner ecosystem, and we are really proud to be part of that ecosystem. So any product from Citrix which goes into Red Hat OpenShift is kind of certified by the OpenShift and the Red Hat team. So the container form factor of ADC or the Ingress Controller, which I'm going to talk about, goes through the rigorous scan of Red Hat security and make sure all the libraries and modules are compatible. So we are proud to be certified partner with that one. And then with OpenShift 4.x, as you know, with the CoreOS acquisition, Red Hat OpenShift has embraced this operator lifecycle, and Jacob also covered a bit in that. we are a certified operator with OpenShift as well. Not only that, as we are moving towards this continuous integration, continuous delivery, and GitOps principle, having an automation module, again, certified by Red Hat becomes very important. So, and we are also Red Hat Ansible certified solution. So you can go to Ansible Tower portal and look for Citrix, and you will see all kind of modules which you can integrate in your automation environment. Right. So now let's get deeper into what kind of integrations which we have with OpenShift. Right. So basically, we are responsible for application delivery and security. Your applications reside in OpenShift cluster, right? And OpenShift has different ways of exposing those applications. Most common being OpenShift Route, and of course the Ingress, which is quite famous in Kubernetes world. So OpenShift routes, there are 4 different kind of routes. A simple path-based route, where the client comes in and all the way till the end you have a plain HTTP, and you can have a path-based service discovery and routing capability over there, right? So we support path-based routing. The most common one is the edge termination, where the ADC devices take the brunt of the SSL work. You terminate a SSL connection, lot of connections on an ADC, and then you talk plain text or HTTP to your backends. So that is also supported in route. We support that as well. And sometimes customers have a choice where they want to put the SSL integration in the application itself. So we allow this pass-through mode, where we are just seeing through the traffic and then making sure the application does what it is supposed to do. For more secure environment, again, you can do re-encryption, where there is one SSL session which is terminated on the ADC, and then there is another SSL session which is to your backend. So re-encryption method. We support all of these 4 routing components which come out of OpenShift. Not only that, things like doing canary, or weight-based load balancing, we support all of those. Not only the routes, the whole Ingress is also supported with our product. And once I'm done with this introduction, I'll get into the deep as to what the product consists of. We are in the world of networking, and as you know, OpenShift has a very pluggable SDN component associated with that. So obviously, by default, it comes with OpenShift SDN. So we support all the different flavors of SDN which comes with OpenShift. Plus, they allow plugins with vendors like Calico, Flannel, Weave, and we do support all of these CNI vendors. Okay. So when it comes to best practices and making sure the application is delivered in a nice way, it's very important to have a flexible architecture, and which can provide customer choice because of the way the enterprises or different roles and responsibilities within the organization, etc. So let me cover those architectures which are quite common, right? So I kind of split them into a north-south. By north-south, I mean getting the traffic to the cluster and then applying policies to that. And the second is east-west, where the traffic is kind of restricted to the cluster or intra-cluster as well, but there is no access from outside client to that. So talking about north-south, these are fairly straightforward 2 architectures which you see. We call it a unified ingress and a 2-tier ingress. So in the unified ingress, you have a Citrix ADC, which is outside this cluster. The solid line represents an OpenShift cluster, and you can have a Citrix ADC outside. So now this ADC can be a virtual form factor or a hardware box, and then we have we can get the policies from the OpenShift API server and use this component called CIC, which is Citrix Ingress Controller, to configure the ADC. Right. Also, this requires a bit of networking and platform team coming together to make this solution happen. For example, the Citrix ADC over here can offload some of the tasks like web application firewall or do SSL termination, etc. Sometimes, you go to an organization where there is specific needs for their applications, right? So we allow them to go at that speed with this two-tier Ingress architecture, where you can literally have a container form factor of ADC shared between different team members who have different needs. And of course, the ADC, which is outside the cluster to attract the traffic to the cluster, basically attracting it to the container form factor within the ADC, and completely automated, right? So we provide these kind of choices to customer to get their application out there. I think one of the limitation, I would say, is the visibility or the observability part of it, because even when the traffic hits the cluster and the container form factor of ADC, there is involvement of kube proxy, the IP table based load balancer, and things can get lost over there. So for those customers who are very keen on having detailed pod-to-pod traffic visibility and stuff like that, we support these two environments. Service mesh, of course, service mesh is quite popular. The same ADC which I showed you from a big hardware box to a software version, we took that same software and kind of reduced the memory footprint and the size of that ADC to participate in a sidecar, in a service mesh environment as a sidecar. So we support service mesh, which comes with OpenShift. We have an operator which is certified with that as well. So if you have plans to use, OpenShift's service mesh, we nicely integrate into that as a data path. And then the service mesh lite. What we soon realize is, maintaining the service mesh is slightly bit complicated, or you need a lot of expertise to get there. So we designed something called as service mesh lite, where we take the existing Kubernetes construct and kind of design the application policies in such a way that the traffic between the pods, the application traffic between the pod, goes through application delivery controller, right? So that way you can have you can do troubleshooting, and you can observe pod-to-pod traffic and have more, inspection of those traffic, which is kind of key for having a complete, secure, and visible environment. So now, what does this stack comprise of, right? So the heart of the solution over here is the Ingress Controller. The Ingress Controller basically is watching the API server of OpenShift based on changes in the endpoints, or adding ingress objects or route objects, and so on and so forth. And basically it keeps track of that. And then on the other end, it basically goes and configures the ADCs, which could be inside the cluster as a container, or it could be outside, as a hardware or a virtual machine. And we are able to do this very easily and seamlessly because these ADCs talk the same language, right? So they are built with the core principle of having consistent APIs, and they talk the same language. So this Ingress Controller is the heart of the solution. It is delivered as a pod in a cluster, which is certified with OpenShift. And basically it can take all these policies and consume, and we can consume it for application delivery controller, right? And typically customers don't have a single cluster, they have multiple clusters. So we can tie all those clusters together, and I'll cover that as well with our multi-cluster story around that. And you have so many application delivery controllers spread across these different environments. We have a single pane of glass called as Citrix ADM, which is Citrix Application Delivery Management, which can be used to manage all these ADCs in different locations, right? Cloud or on-prem. Not only that, OpenShift comes by default with these observability tools like Prometheus, Grafana, Elasticsearch, Kibana, and Zipkin. So we designed another component called as Citrix Observability Exporter, which basically gets all those time series data metrics from these ADCs, and as they are close to the application, there are a lot more information about the application. You can take that data and ingest into any of these open source tools on your side, right? So we also have created this observability exporter, which you can use. Also, networking becomes very important. You need to participate into the networking of the OpenShift cluster. So we designed something called as node controller. Basically, it is used to automate the plumbing of VXLAN tunnel into your OpenShift SDN. That way you have access to the pod network, and we have also created kind of a container for that, so you can have your ADCs anywhere, right? As long as there is a layer 3 reachability to the nodes, we can participate in the pod networking as well. We have developed few other components, like we have our own IPAM controller, basically to attract the traffic to an IP address. You might have a lot of IP address to manage. The IPAM helps you to kind of automate the configuration of those virtual IPs or VIPs on these ADCs. And you can have different policies. Those policies are a simple key value pair, which you could use to kind of configure your ADCs. Okay. So when it comes to operation, right, across all these clouds, and so as you know, OpenShift has multiple flavors, right? Other than the on-prem version, they are now available in Azure, they are now available in Amazon, and so on and so forth, right? The functions which Citrix provides remain the same, and that's what I'm highlighting over here, right? SSL, WAF, bot management, API gateway functionality, layer 7 traffic policies, all of those are available in these different environments, whether it is OpenShift running on-prem or running in the cloud, right? And we can tie all of these environments together with our Citrix ADM product, where we can manage things like auto scaling in the cloud, turn on the observability stack to look at your application at these different environments. And then, of course, there is Citrix Observability Exporter as well, which can run in one of these environments. And as long as it has access to your ADC, it can take all the data and export it into your open source tooling as well, right? And this is all completely automated. You can automate all of these processes. So, the very basic way of configuring the Citrix Ingress Controller, there are various features and functions. We are heavily focused on custom resource definition, but there are other ways which we configure our ADCs as well. So when you define a route or ingress object, you can use annotation if you want to use any of these features, right? Like configuring a virtual IP, or to use a certain port, or to do canary. So you can use annotations for that. And this is kind of out of the box construct from the Kubernetes world. Annotations, you can use those. And then there is smart annotation, which is kind of slightly more opinionated or more closer to way the Citrix works, like different load balancing methods, health check, pointing to a certificate. Those are all done via smart annotation, right? Some complex configuration can be done through CRDs. Like the quite popular one is the rewrite responder, which can be done through CRDs, or doing things like multi-cluster service discovery or traffic management that can be done through CRDs as well. And then a lot of API gateway function, authentication, rate limiting, etc. can be done. Layer 7 based routing, all of them are through CRDs. Also, we have few config map options, basically when it comes to integrating things like COE or configuring, what kind of log you want, etc. Or if you want to do any changes to the way the ADC is, you need to communicate to ADC for management purposes, or those Nitro API ports. We use config maps for those. And for more network-oriented cases, things like using certain protocols like WebSocket or gRPC, etc., you can use the HTTP profiles which we have. If you have application which needs certain TCP protocol to be used, like TCP window scaling or selective ACK, etc., we support that as well. And then if you have specific ciphers, etc., we have different SSL profiles which can enable that, right? I think when it comes to cloud native application, faster deployment and accurate deployment becomes very important, and that's where GitOps come into picture. And we are tackling this GitOps or CI/CD in two ways, right? So one is, of course, we are certified with Ansible. So this Ansible can participate in your GitHub. Basically, it has integration with your CI. Most typically, it is a Jenkins or something, and then the Ansible has webhooks to kind of get the state from your source code, and you can pick that and trigger the Ansible modules to get your end state on the ADCs, and Citrix participate in that as well. And then, of course, when it comes to OpenShift has various CI/CD pipelines and GitOps. One of them being Argo CD, or you can use Flux CD or Tecton. Through that, and that's what I'm going to show you today, is like we integrate seamlessly into the GitHub architecture as well. Right. So now I'm going to start showing you the demo, and it is split into various parts. First, I want to showcase the integration of our operator. Right, we are a certified operator, so I'm going to talk about that first, and then I'll show you how easy is it once the operator is in place. How easy is it to expose this application using the GitOps? So I'm going to use Argo CD with OpenShift to do the same. And then my second set of demos is around the multi-cluster, right? So the best practice to kind of have a resilient and secure application delivery across these different environments with things like disaster recovery or active-active. I will showcase the multi-cluster use case. And if time permits, which I don't think we will have, I can kind of show you the observability aspect as well as to what we deliver through Citrix ADM and our Citrix Observability Exporter. And again, if the time permits, we can cover the security part as well. So let me just quickly jump into the demo. Before I do that, I just want to show you what I'm doing here. So I'm gonna install the operator, and then I'm gonna show you how once the code is committed into the branch, the main branch or the branch of your choice, we'll use Argo to pick up those manifests and then configure the end state, right? The end state could be any of those devices, Citrix ADC devices, which I'm showing here, and we can configure those. Okay, so before I dive into the demo, this is what I'm going to show you. I will have OpenShift cluster running. I'm going to install the Citrix Ingress Controller using an operator. And then that Citrix Ingress Controller is going to be responsible for configuring the VPX, right? So I'm going to define Ingress object, which will be picked up by the CIC, and then you'll see I can access the application based on the rules you have defined. Okay, so let's get to the demo. Okay, so this is OpenShift 4.x. I'm going to show you. So to save, let me go to the operator hub first, right? So if you go to the operator hub today, and if you just type in Citrix, you will see all kind of operators which we are certified with the OpenShift. For example, integration with the service mesh with the Istio sidecar, or using Istio Ingress gateway, or those the Citrix Ingress controller, which I'm going to show you. Also, we have operator with API gateway. And if you are interested in doing a two-tier architecture, we have CPX with Ingress Controller as well, the container form factor. So what I'm going to do is I'm going to show you operator in action. What I have done so far to save time is I have installed it. It's just a couple of clicks to get this thing going. So I have already installed here. So let's go and take a look. So it is this one over here. So now what I'm going to do is I'm going to create an instance of this operator so that it can start going and configuring the ADCs, right? So I'm going to create an instance. Okay. So basically, this is a pretty straightforward. All I tell it is, this is the IP address of my ADC. This is the credential which I'm going to use. I have already pre-created a secret for that. And then, there are some fields, they are all optional except for, you have to accept the EULA, but everything else is optional. Okay, but just for cleanliness, I've used things like Ingress class and service class, etc. So I'm going to go ahead and just say create here, and then we should see the pods coming up. Wait for some time. There you go. So it's creating right now. So that's the installation of CIC into OpenShift environment. Pretty straightforward. Okay. So while that is happening, it's running. So it's now basically it has all the associated rollback with that, and now it is watching the API server for any changes. So now this is where we'll make some change. Okay, so now let's get into the whole GitOps principle. What I have is I have already installed a Argo CD here, and I have this repo over here, right? So I'm going to access this repo right now. As you can see, there is nothing over here. Let's say I want to deploy an application. The CI will kick in. It will take care of the things like, based on my code changes, I'm going to create a Docker image. I'm going to push it to a registry. I'm mainly focusing on the delivery part in this one. So let me go back. So this is my Git repo, which is right now connecting. So what I'm going to do is I'm going to copy over my app information over here. I'm going to show it to you. What does it have? And then my app one Ingress, over here. Okay, so let me just show you the app. Okay, so the app is pretty straightforward. I have a deployment. It's listening on port 80, and then it has the Docker image from where it has to pull, and then I have a simple app as well. Right, so ingress.yaml. All I'm saying is I want to access this app on this IP address, which is configured on the ADC, and it's listening on port 1. And my roles are going to be that it's going to be app1.example.com. Okay, so I think I added the file. So let me do that here. We do git status just to make sure those two files are in there. Okay. And let's commit it. Okay, and I'm going to push it. So while that is happening, we should see those files being pushed here. So those app1 were pushed like 11 seconds ago. Now let's look at the Argo CD over here. Let me do a refresh. So it's fetching from there you see the app, and the ingress is fine. So now let's try to access this. So we gave it app1.example.com. And there you can see that, the Citrix ADC was able to pick app1.example.com. It resolved it to the VIP of the ADC virtual IP, and it can easily go and access the app. Okay. Let me go back to my presentation. Is this guy? Yeah. So that concludes the part 1 of the demo, where I just showed you a simple operator install, and then how you can use a GitOps principle to kind of expose your app and can access it, right? So now let's come to one of the recommended best practices to make sure that your applications are available. In case of depending on your business need, right? So I'm going to cover this multi-cluster solution. I'm going to introduce what is multi-cluster. Then we'll look into different use cases, right? You might have all on-prem, so you might have clusters across different geographical zones, how you can deploy a given application, and then make sure that you reach this application, which is live is healthy. You can always monitor and sync between these clusters, and that's the capability which we provide through our product. You can have a hybrid environment. You might have an OpenShift running on-prem, or you might have an OpenShift running in, say, Azure or Amazon, right? So how do I make sure that, whoever is available, I reach to the right application? That way, say, for example, your on-prem goes offline for some reason, I should be able to seamlessly direct that traffic to the OpenShift cluster, which is running in one of the clouds. Or it could be, cloud to cloud. So you might have your application running in OpenShift in Azure and another one running in AWS. You can use our product nicely to tie it together. And then I'm going to show you another a very primary use case. There's a lot of OpenShift customers are moving from OpenShift 3 to OpenShift 4. We can really help in that migration use case with our multi-cluster solution. Okay, so if you remember the slide, I kind of talked about all the different component. We have created something called as a multi-cluster controller, which is an additional function to our Ingress Controller, which runs in the cluster. It's also delivered as a pod. Basically, this is used to configure your GSLB devices. So GSLB stands for Global Service Load Balancer. This is quite popular amongst the customer base of Citrix, and we are using that technology to kind of enable application delivery across these different domains. Okay, and how do we do that? So we created two simple CRDs. GTP stands for Global Traffic Policies, and GSE. GSE stands for Global Service Entry. Basically, GSE is to kind of tell you where your endpoints are, right? So that you route the traffic to the right cluster. This GSE component is automated for both Ingress and service type LB. So you don't have to actually use it. As long as you have the CRD, we will automatically pick up those information. GTP is where you can define these different policies, right? So if you want to do a simple active backup or like kind of a failover kind of algorithm, you could use that. Or you could use canary, where you want to split the traffic across these different data center. Or you can use policies like local first, right? So for example, if the request is coming locally, I want to just go there. I don't want to go out. Or you can use RTT-based algorithms, right? So wherever I get the response time faster, I want to go there, right? You can define all of these policies using GTP. Okay, so I think I kind of covered this use case. So you might have multiple data centers or your cluster spread across different failure domain. We can enable using Citrix ADC to kind of deliver the traffic. Right? You can have this on-prem and public cloud kind of an environment. We can do that. You can do it across different cloud as well. Amazon or Azure, you could use Citrix ADCs there to kind of route the traffic. So poll question at this point of time.
All right. One more, folks. Do you plan to deploy the same app in multiple clusters? Oh, I'm sorry. It's not pushed out to you yet. Let me do that first. Here we go. That should be popping up on your screen right now. Do you plan to deploy the same app in multiple clusters? Yes, with failover option. Yes, with active. No, or not sure. All right. Just take a couple seconds, and you wouldn't mind logging your responses for us, and then Pushkar can talk you through the results here. All right. Give it another couple seconds for folks to answer. All right. All right. I'm going to close that poll out there. Oh, no, we still got another couple coming in. Okay. We'll call it a day there. So it looks like 54% said yes. Again, 0% said no, and 46% said not sure. So Pushkar, what are your thoughts on that?
This seems same answer as the previous poll question. Interesting, right?
Yeah.
Yeah, agreed. They seem to be on the fence, so hopefully this information will help them make that decision to join the movement, right, and leverage these amazing technologies.
Yeah. So typically every organization has this crown jewel kind of application, or the application which turns in a lot of money for the organization, and you would want to have this kind of a resilient environment where you have active backup or active kind of an environment, or just providing a better customer experience to the user, right? The better experience to reach to the nearest cluster. So this is a very important piece of app delivery. So I think folks on the call should seriously consider this as well. Okay, so now back to the demo. This is going to be a quick one. We don't have enough time. So basically, I showed you how I use this operator to create and kind of deploy the application. What I'm going to do is now I'm going to move it across different clusters, right? 2 clusters. So I already have OpenShift 3.x, which is doing the same thing which I showed you with OpenShift 4.x. It has an app running. And what I'm going to do is I'm actually going to fail over. So in this case, let's take the use case of, you're migrating from, say, OpenShift 3 to OpenShift 4. You would kind of have this multi-cluster environment. And then what I'm going to do is eventually you're going to take that app away from OpenShift 3, right? So I'm going to create that failover, and you will see that the traffic will seamlessly fall over into the OpenShift 4 cluster. Okay, so it's going to be something like that. So I'm going to go back to my screen here. Okay, so this is my OpenShift 3 cluster, which I'm entering right now. Okay, it has, and let me go to the client as well. So I think I must have client somewhere here. Okay, that's the client. So as you can see, I have a continuous script running here. I seem to have lost connection to that. So let me open it again, SSH. Yeah, so it's a simple while loop. I'm going to access that app1.example.com. Right now, OpenShift 3 is responding. So what I'm going to do next is I'm going to use Git again, okay? And I'm going to copy over GTP. I'll show those YAML files. So this is the CRD called as global traffic policy. And what I'm going to do is I'm going to do a failover. In the failover, my primary data center is this OpenShift on the east side. This is actually this guy, which is OpenShift 3. And then I'm going to fail it over to OpenShift 4. And you will see that this application will start responding from OpenShift 4. So let me add the files. Right. I'm going to do a git push. While that happens, back here, make sure it's here now in my repo. So there I deployed the repo. I should soon see, there's my traffic policy and service entry. And what I'm going to do next is I'm going to go back to my OpenShift cluster here. And I'm going to delete my app. And the app on OpenShift 3 is now deleted. You should quickly see a failover. So there you go. Now it says I'm reaching the app, which is now deployed on OpenShift 4. So that's the multi-cluster demo.
I'm really sorry to have to cut you off, Pushkar. We've got 1 minute to the top of the hour, so I just need to remind the audience that this has been recorded. So if you missed any or all of it, you'll be able to go back and watch it again. We will send an email with instructions for how to access the webinar on demand. You can also visit us at devops.com/webinars. I went ahead and grabbed our Amazon winners this time. This time we've got James S., Mark F., Jason B., and Ara A., who congratulations to all our winners. And you'll also be getting an email with instructions for how to claim your gift card. So check your email inbox. If you don't see it there, make sure to check your spam folder. As always, thank you so much for joining us today. We hope to see you again soon. Thanks so much to Jacob and Pushkar for your awesome presentation. My name is Sharon Florentine. I'm signing off.
Cheers, everyone.